Hello students, I hope all of you are doing well. So in this video, we will be discussing current electricity PYQ from 2016 to 2023, right? All the NEET PYQs from 16 to 23, we will be looking at it. Let us start one by one, we'll see. So the first question that we have is, it says, the resistance of platinum wire at 0 degrees Celsius is 2 ohm. Okay, resistance is 2 ohm at 0 degrees Celsius and 6.8 ohm at 80 degrees Celsius. Fine. The temperature coefficient of the resistance of the wire is temperature coefficient. What is our temperature coefficient? Alpha. What is our relation for variation of resistance with temperature? So this, let us call it as your R dash. I am terming the resistance at 80 R dash. What is it? R dash is equals to R 1 plus alpha delta T, right? This is what is our variation of resistance with temperature. So we can write down 6.8 is equals to 2 1 plus alpha is our temperature coefficient, delta T 80 minus 0, it will be your 80 minus 0 80 only. So we get over here 3.4. 3.4 is equals to 1 plus 80 alpha. We'll get over here 2.4 is equals to 80 alpha. So alpha value comes out 24 by 800, which becomes 3 times. So 3 into 10 power minus 2 degrees Celsius inverse. 3 into 10 power minus 2 degrees Celsius inverse. This will be the answer. Option number second. Second option is our correct answer, right? Yeah. Next question, again 23 question only. So it says 10 resistors, each of resistance R, are connected in series to a battery of EMF E. Fine. 10 resistors are there, each having resistance R. Like this, we have 10. They are connected in series to a battery having EMF E. Fine. And negligible internal resistance. Okay. Then those are connected in parallel to the same battery. The current is increased by N times. The value of N is. Okay. Now, these are when connected in parallel. So, if we make it, what it will become? R like this, we have 10 times, which is all these connection in parallel we have with our cell E. Okay? EMF. So they are asking us how much the current is increasing. So let us find out over here. What can I write it? Current IS. IS is current in the series. It's visible? Visible. Current in series, what can we write it? E by R equivalent. What is our R equivalent over here? R plus R plus R plus R 10 times. That means R equivalent will become 10R. So IS value comes out E by 10R. Fine, well and good, right? Second, over here if we write down your R equivalent in parallel R equivalent is identical R, which are 10 resistors. 10 identical resistors are connected in parallel, so it will become your R by 10. Fine, let us write down current in parallel. Current flowing in parallel connection, this will become IP is equals to E by R by 10. Fine. So this is our second equation. Solving first and second, what do we get? IP is equals to 10 times E by R, 10 into E by R. Now over here from first equation, we know E by R value is 10 times IS. 10 times IS. So what do we get? Current in parallel will be 100 times of IS. So it will increase by 100 times. N value will be, so the current is increased N times, that means N value is 100, right? Yeah. Next question is, the magnitude and direction of the current in the following circuit is. Now this is the circuit that is given to you. 2 cells are there and 3 resistors are there. Now if you notice carefully, the 2 cells 10 volt and 5 volt are connected like this. Observe carefully. This is your 10 volt and this is your 5 volt, right? If you notice, this is your opposite polarity. The cells are connected in opposite polarity. Fine. And then you will have 2 ohm and this one is 1 and 7. Fine, well and good. So they are asking us basically current and the direction of current. How to deal with it? It's a question from your multiple cells, right? Multiple cells are there and cells are connected in series but with opposite polarity. So what we will get? E equivalent can be written as E1 minus E2, which becomes your 10 minus 5. So it's 5 volt. Ultimately, all this we can redraw it as this will be 5 volt E equivalent, and as we can notice that beta, according to this the polarity will be decided. This is positive negative, this is positive negative, so plus minus, and the current will be flowing from positive terminal to negative terminal in the conductor according to the larger EMF cell. And according to the larger EMF cell, that means current flow will be in this, it will be clockwise, this will be the direction. Fine. Now as we can see, all the resistors same current is flowing, that means they are in series. Therefore we can say 1, 7 and 2 are in series, which becomes your 7, 3 is 10 ohm. So what is our current value coming? Current can be written as V by R equivalent, which is V or E, it's okay, no internal resistance is there, so it will be same only. And so 5 by 10, that implies your 1 by 2 ampere. 1 by 2 ampere from, if you see, this is the direction. And options, if you see option number 1, it will be 0.5, 1 by 2, 0.5 ampere. So option number 1 is our correct answer. So next, a theoretical question, simple question basically. The reciprocal of resistance is resistance reciprocal, that is 1 by R is basically denoted by G, and we term it as conductance, right? It is reciprocal of resistance is conductance denoted by G. Fine. Okay. Again, next, it's a theoretical question only. What it says, as the temperature increases, the electrical resistance. So 4 options are given to you. They are talking about your, for conductors what happens and for semiconductors what happens. So beta, for conductors, as temperature increases, your resistance also increases. Resistance also increases because number of collisions increases, therefore. Whereas for semiconductors, as temperature increases, resistance will decrease. Resistance decreases because the number of free electrons increases in semiconductor, that's why your resistance decreases. Here alpha is positive, whereas over here alpha is negative. All this information is not required, but just, they are only asking us what happens to conductors resistance and to semiconductors. So for conductors resistance increases, for semiconductors it decreases. Fine. This I have written this thing, and alpha is the thermal coefficient. For your conductors alpha is positive, for semiconductors alpha is negative. Fine. Yeah. So our next question says, a copper wire of length 10 meter and radius 10 power minus 2 by root pi. Fine, let us see. Length is 10 meter, radius denoted by small r is 10 power minus 2 by root pi. Fine. Has electrical resistance of 10 ohm, resistance capital R is 10 ohm. They are asking us the current density in the wire for an electric field strength of 10 volt per meter. Current density they are asking, current density is J for electric field of 10 volt per meter. How to do this? So let us see beta. They are asking us current density, electric field is given to us. A very standard result is there. What is that? J, current density is equals to sigma into E. Current density is equals to conductivity into electric field. So over here we can write J is equals to conductivity can be written as your reciprocal of resistivity. That means, or we can write sigma as 1 by rho, because conductivity is nothing but 1 by rho into E. Fine. Over here E is given to us, but sigma, this rho is not given, resistivity is not given to us. So but all this information is given to us. Using this we will write down our resistivity. How? R is equals to rho L by A. From this I can write it rho is equals to resistance A by L. Fine. Over here we have got this and this equation. Let us substitute the two equations. Let's solve this. So J is equals to E by this rho, E by rho value is how much? RA by L. It goes into numerator. So we are getting your current density as EL by RA. Let us substitute value of each term. Electric field is 10, length is 10, resistance is 10, area will be how much? Radius is given to you, area will be pi r square. So pi into 10 power minus 2 by root pi whole square. Fine. 10 cancels out. So J is equals to 10 by, this is root pi square. So this one value will cancel out. We'll be having over here 10 power minus 2 whole square, which is 10 power minus 4. Right. When we simplify it, it goes in numerator and it becomes your 10 power 5. So current density value comes out to be 10 power 5. Right. Which option it is? Option number 3. Option number 3 over here will be our answer. Yeah. Our next question is, the equivalent resistance of the infinite network given below is, that means this is over here the circuit, as you can see it. I have also drawn it on my board. So good question. See over here carefully. The equivalent resistance for infinite ladder. How to deal with these infinite ladder questions? So what happens is, it's an infinite ladder. Please understand this. That means basically these patterns, what pattern? 1 1 1. This 1 1 1 is getting repeated again and again. This is what is happening. This is how, if you notice carefully, if I remove these 3 1 ohms, it will not affect the whole circuit over here. If I remove this 3 1 ohms 1 1 1, if I remove it, it will not affect the whole resistance. Why? Because over here they have given this is infinite ladder, and this part is getting repeated over here. This part is getting repeated over here. 1 1 1 is getting repeated over here. That implies you find out R equivalent between these 2 points AB, or you find out R equivalent between these 2 points, the one that I am marking P and Q. It will be same only. It will be same only, because if you remove from infinite ladder, if you remove one part which is getting repeated and then forming the whole ladder, that means your R equivalent will not change. So what we do is, we over here, let's say if we cut it from here, that means whatever will be the R equivalent between A and B over here, if we connect a cell over here, let's suppose, and whatever is R equivalent between A and B, same R equivalent will be for this whole thing also. And for this whole, whatever is the R equivalent, same R equivalent will come for this whole part also. Let's say the R equivalent between A and B is your X. Let's say R equivalent is X, between these. That means for this whole part, because if we remove one part, it does not affect the infinite ladder of resistors. If we remove these 3 only, which are getting repeated and forming the infinite ladder, it does not affect the R equivalent. And therefore, if here it is X, that implies for this whole part also your R equivalent should be X only. So I will redraw it. What can we do it? This 1 1 and you have 1 ohm, and this whole part, either you take this full or you remove this, and if you consider only this part, this will also have R equivalent as X only. That means this is your X. And what is R equivalent for this between this A and B? If we take it, it will again be X only. So let us see now what we have got it. This is your 1 ohm. I hope till here everyone has got it, what we have used over here, what concept we have used, or how we have approached this question, right? So these two are in parallel. If these two are in parallel, we will get over here 1 ohm. 1 and X in parallel becomes R1 R2 by R1 plus R2. That means X by X plus 1. 1, and over here between A and B, it is your X only. Now what do we get? 1 ohm, 1 ohm, and X by X plus 1 are in series. So these 3 are in series. That implies 1 plus 1, 2, 2 plus X by X plus 1. This is the R equivalent, and this must be equals to your what? the total R equivalent for the infinite ladder, which is equals to X. Fine, let us simplify this. So what can we write it? 2 minus X is equals to X by X plus 1. I'll get it over here. 1 minute, or we can write it like this. X by X plus 1 is equals to X minus 2. X is equals to X minus 2, X plus 1. What are we getting? X is equals to, if we simplify this, X square plus X minus 2, X minus 2. X cancels out. We have got a quadratic. What is the quadratic we have got? X square minus 2X minus 2 is equals to 0, right? This is the quadratic we have got. Let us find out the solutions for this quadratic. The solutions for this quadratic, is it visible there? Yes. So solution for this quadratic, we can write X is equals to minus B plus minus root over B square minus 4AC by 2A. Minus B, minus of minus 2, that is your plus 2, plus minus root over B square, that is 4B square minus 4AC. A value is 1 and C value is your minus 2. So minus of minus 2 by 2A. So X is equals to 2 plus minus root over 4 2 is 8, 8 plus 4 12 by 2. X is equals to 2 plus minus root 12. Root 12 will be root 12 will be your 2 root 3. 2 root 3 by 2. Now if you notice carefully, we will get two solutions over here. 2 plus 2 root 3 by 2, 2 minus 2 root 3 by 2. One is positive, another is coming negative. We will leave the negative solution and take the positive solution, which will give us X is equals to 2 plus 2 root 3 by 2, which 2 taken common and cancels out. So we get X is equals to 1 plus root 3. X is equals to 1 plus root 3, right? So this is our answer. I hope you got it, how to do it. It was a decent question, good question. And many times in your coaching modules, this is a very common question also, but it's a good question, how to approach this. Fine. Okay, let us look at our next question. Yeah. Our next question says, a cell of EMF 4 volt and internal resistance 0.5 ohm, okay, cell of EMF 4 volt and internal resistance 0.5 ohm is connected to 7.5 ohm external resistance, 7.5 ohm external resistance. The terminal potential difference of the cell is, terminal potential difference of the cell, terminal potential difference, these are the terminal potential difference formula. You people may be knowing it. It is given as VAB is equals to E minus IR when the cell gets discharged. And for that we will require our current. There is one more way. Whatever is the terminal potential difference, same is the potential difference across, because single resistance is there. So same potential difference will be across this 7.5 also. So you can also write this will also be equals to current into this capital resistance, that means external resistance R. And for both of them we need current. So let us first calculate current value. I value will be what? Current will be flowing like this from positive to negative in the conductor. So it will be E by R equivalent. Current is E by R equivalent. How much is EMF? 4 by R equivalent. 7.5 and 0.5 are in series. So that is 8. 1 by 2. 1 by 2 ampere is our current. Let us calculate potential difference or terminal potential difference. V is equals to I into R. R is how much? 7.5. When we solve it, we get 3.75 volt. 3.75 volt is our answer, right? Yeah. So the question says two resistors of resistance 100 ohm and 200 ohm are connected in parallel. Fine. 100 and 200 are connected in parallel in an electric circuit. The ratio of the thermal energy developed in 100 ohm to 200 ohm is given. Okay, in given time is. Now, what is there? Extra information is not given, but what is given is that these two are in parallel. These two are in parallel. That means what will be common for them? Potential difference will be common. Heat produced. How do we write down heat produced? I square RT. But over here, we will be using our relation of V square by R into T. Heat is I square RT. Most of the time we use I square RT, but I square RT or V square by RT. Over here we will use this relation. Why? Because what is common for the two resistors? Potential difference is common. So we can see carefully that heat is equals to V square by R into T. For these two we can write it. So H is inversely proportional to resistance. So what can we write it? H1 by H2 is equals to R2 by R1. If we do it, R2 by R1, that is your 200 by 100, it comes out H1 by H2 comes out to be 2:1, right? Fine. Let's look at the next question. Yeah. So our question is, it's basically a match the column. It's a match the column. So what we have is in column 1 some quantities are given to you and we have to find out the relation. We have to match with the relations that are given in column 2. First is given to us drift velocity. But a drift velocity Vd is what? Vd is given as E by m into tau, है ना? So this is what it is. Which option it is given? R option. So A is given to us as R. Fine, well and good. Second is electrical resistivity. Electrical resistivity, you can write it as your RA by L, or also we see from the options that are given to us, in that we know that J is equals to what? J is equals to sigma into E. Current density is equals to conductivity into electric field, right? So J can be written as, conductivity can be written as 1 by rho, that is resistivity, into E. So rho, that is resistivity, is equals to electric field by current density, that is your E by J. So which option it will be? S option. So B is S option. Third is relaxation period. Relaxation period is tau, and tau is basically your m by n e square rho. M by n e square rho. And all these relations are factual relations. Basically, obviously, we derive many of them, but this is something that you should know it, all these relations. Last is current density. Current density is J is E by rho, but the one more option that is left is, you can answer it, this C value will be basically P and D is left. So current density, if you see, current density is J, we know I is equals to what? NEAVD, है ना? Current is current, relation between current and drift velocity, I is equals to NEAVD. I by A, if I take A in the denominator, it becomes your NEVD. I by A is what? Current density only. So J value is equals to NEVD. Now see over here which option it is? Q. Q option. So D is Q. Now RSPQ, you can check the options which are given to RSPQ. Option number 3. Option number 3 is our correct answer, right? Yeah. So our next question is, three resistors having resistance R1, R2, R3 are connected as shown in figure. Basically your R2 and R3 are in parallel, which is connected in series with the R1. Okay. The ratio of I3 by I1. Ratio of I3 by I1. What is given to us? Let us draw it. Three resistors are there. This one is your R1. This one is R1, this is your R2, and this is your R3. This current is I1, I2, I3. Fine. I1, I2, and I3. They are asking us ratio between I3 and I1. How to do it? Because it's about your current distribution. Current distribution, if we have to write down, current in resistance R3, if we have to write, I3 is, what is our relation? Opposite resistance by total resistance. Total is R2 plus R3 into total current. Total current is I1, है ना? So I3 by I1 comes out to be R2 by R2 plus R3, right? Now you check the option, which option it is given to us? R2 by R2 plus R3. Option number 2. And options are little smaller in size, but I hope you can see it. It is option number 2 is our, according to this, option number 2 is our correct answer. Fine. Let's look at our next question. Yeah. So a question is, which of the following graph represents the value of resistivity with temperature for copper metal, right? For copper. So copper is what? copper is your metal, copper is a metal, and we know that your resistance or resistivity value increases as temperature increases, resistivity also increases, right? Resistivity also increases because the collisions will be more frequent, that's why your relaxation time decreases, and due to that your resistivity increases. Now the thing is, so from this if you will see, option number 1 and option number 1 and option number 3 are gone, because in these two options your resistivity is decreasing. We are left with option number 2 and option number 4. Now beta, we should also know this, that as the graph is, it's not a linear relation, it comes something like this, you know, it's a parabolic relation between resistivity and temperature. The relation is parabolic, it will increase, and how it will increase, kind for parabolic relation, right? Let's look at our next question. Yeah, next is this is last question. Next is the solids which have negative temperature coefficient of resistances. Again a theoretical question, we discussed it in the starting also, that your your metals have positive temperature coefficient. Metals, these have positive temperature coefficient, that means alpha is positive, whereas for semiconductors and insulators alpha is negative. For semiconductors and insulators alpha is negative. You should keep this in mind, right? That semiconductors and insulators, your alpha is negative, because in semiconductors with increase in temperature the number of free electrons starts increasing, and therefore the resistivity starts decreasing in that. That's why your alpha comes out to be negative in that. Fine. So these are, option number 1 will be our correct answer, right? Yeah. So next question is, a charged particle having drift velocity, that is Vd, 7.5 into 10 power minus 4. This is a drift velocity given in electric field of E is equals to 3 into 10 power minus 10. Okay, these are the values given. The mobility is, mobility they are asking, what is our relation for mobility beta? Mobility is given as Vd by E and a drift velocity by electric field. So we can write down 7.5 into 10 power minus 4 by 3 into 10 power minus 10. So we will get over here, if we simplify it, if we see 7.5 by 3, so we'll get over here 2.5 into 10 power 6, and 2.5 into 10 power 6, which is our option number 2. Option number B is our correct answer. Fine. Yeah. So our next question is, a resistance wire connected in the left gap of a meter bridge balances a 10 ohm resistance in the right gap at a point which divides the bridge wire in ratio 3:2. Fine. So quickly let us draw the meter bridge setup. So if we see two boxes and our meter bridge wire, over here galvanometer, and you have our cell. Fine. Now what it says is, in the left box we are using a resistance wire, let's call it as R, resistance as R, and on the right box it balances 10 ohm resistance when the null point comes at the length of 3:2. The null point, or basically this divides the length of the meter bridge in the ratio of 3:2. So beta, they are asking us, last it says, if the length of the resistance wire is 1.5 meter, that means this one length is 1.5 meter, then the length of 1 ohm of resistance will be length of 1 ohm resistance. Fine. If this resistance wire is of 1.5 meter length, then how much will be the length of 1 ohm? So first of all, let us calculate how much is the resistance of this wire. What can we do? Our meter bridge, based on principle of your balanced Wheatstone bridge. So over here we can write down R by 10 is equals to, in what proportion your length is getting divided? 3:2. So 3 by 2. So what do we get it? R is equals to 30 by 2, which is 15 ohm. Fine. 15 ohm. That means 1.5 meter we have, or 1 minute, we can see it over here, length of 1 ohm of resistance. Fine. So 15 ohm resistance Basically, we are doing over here unitary method. So 15 ohm resistance is for 1.5 meter length. है ना? So 1 ohm resistance will be for 1.5 by 15 ohm or 15. So this comes out, we will get over here, cancels out, 1 into 10 power minus 1 meter. That means how much will be the length of your 1 ohm resistance? 1 into 10 power minus 1 meter. Which option it is? Option number 3. Option number 3 will be our correct answer, right? Yeah. And next question is, 6 similar bulbs are connected as shown in figure. I have also drawn the circuit over here. Question is given to you. So 6 similar bulbs are connected as shown in the figure with a DC source of EMF E and internal resistance 0. Small internal resistance is 0. The ratio of power consumed by the bulbs when all are glowing, and second, in the situation when two from section A and one from section B is glowing. That means when this is the situation, 2 from section A and 1 from section B is glowing. That means we will get this type of scenario. That means 2 parallel, 1 in series. Okay? 1 from B and 2 from section A. This is your section A, this is section B. So 2 from section A, 1 from section B. Fine. So we have to find out, let's call this as P1 and this is your P2. How to calculate? So EMF is same only. What can we write it? And also it is given to us that 6 similar bulbs. If bulbs are similar, that means their ratings are same. Ratings are same, that means their resistance will be same. So all of them have same resistance. So this is your R. Let us assume R, R, R. This is your R, R and R. What do we have? These 3 bulbs are in parallel. These 3 bulbs are in parallel. R, R, R. How much it will come out in parallel? It will be R by 3. Right? Over here also it will be R by 3. You have cell E. Finally, R by 3 and R by 3 are in series. How much we will get it? R equivalent is 2R by 3. Once we got our R equivalent, we can write down power. Power is basically, which is P1 in this case, power is, we can write down as V square, which is in this case E square. EMF is given to us, so potential difference, internal resistance is 0, so it will be E only, E square by R equivalent, which is 2R by 3. I hope this is clear. Power is basically V square by R. This is what I am using over here. R equivalent for this is how much? R by 3 plus R by 3, 2R by 3. Fine. Next case, this is your R, this is R, this is R, right? What we will have R equivalent over here? R equivalent will be R and R in parallel, which will be R by 2, which is in series with R. So how much we get it? R by 2 and R. R equivalent is R plus R by 2, which is 3R by 2. Now let us write down power P2. P2 is V square by R again, that means E square by resistance. How much is our resistance over here? R equivalent, we got it, 3R by 2. So we can take the ratios now. This is our second, P1 by P2. Is it visible? Down it is visible. P1 by P2 is equals to, if I take the ratio, E square R will cancel, we will get 3 by 2 into 2 by 3. That means 9:4. P1 by P2 is 9:4 is our answer, right? Option number 2 is our correct answer. I hope you got it, how to deal with it. Yeah. So our next question that is given to us is, in the circuits shown below, the reading of the voltmeter and ammeter will be. 2 circuits are given to you in which they are asking us to compare between V1, V2 and A1, A2. Now beta, if you notice carefully, what happens is, voltmeter as a device, we have that voltmeter we want which has very high resistance. A voltmeter should have high resistance, right? And an ideal voltmeter should have infinite resistance. This is what we term ideal voltmeter has infinite resistance. Why like that? This is also 10 ohm given. So why like that? Because if current flows over here, we want that this voltmeter can give our accurate reading of the potential difference across the resistance, which will happen when the current over here does not flow through the voltmeter, which will happen only when voltmeter has infinite resistance, right? So over here, if you notice carefully, in the question they have not given resistance of voltmeter or ammeter, so we will consider them to be ideal only. Now over here, if I goes over here, this will be your I value. Over here resistance infinite, that implies the whole current passes through it. So over here what we will have, R is 10, so we can write I1 value as V by R, which is 10 by 10. How much it is? 1 ampere. Next, potential difference, V1 value will be what? V1 value will be I into R, which is 1 into 10, that implies 10 volt. Fine. Next question over here. In next question, it is saying again your current will be going like this. Ideal voltmeter, now they have connected voltmeter in series with 10 ohm. Nothing is mentioned. Ideal voltmeter, that means this will have infinite resistance. If this has infinite resistance, that means no current will pass through this branch. No current will pass through this branch. All the current will flow through this 10 ohm only. And again, R equivalent for this circuit will also be 10 ohm only. It will not be 10 by 2. Please understand what I am trying to say. Because a voltmeter is connected, nothing is mentioned. Ideal voltmeter, that means it has infinite resistance. Infinite resistance, that implies for this whole branch, we can say that the resistance is infinite. So you have over here only this current is flowing. No current flows through this one. That implies over here you have the current is flowing through 10 ohm only. That implies R equivalent is 10. Again, what can we write? I value will be V by R, that is 10 by 10. So this is I2, which is 1 ampere. Fine. This is what we have got. Now, no current is flowing through this resistance. That means this second voltmeter will be measuring the potential difference across this 10 ohm only, which will be again how much? V2 value will be I, that is 1 into resistance this, because no current flows through this. That implies potential over here is same only across this. So I into R, which is 10 volt, right? V1 and V2 are same, I1 and I2 are same, right? So our option is over here, it will be option number D. Option number D will be our correct answer, right? Yeah. So the question that we have is, a set of n equal resistors of value R each are connected in series to a battery of EMF E and internal resistance R. Fine. N resistors are there like this, each having resistance R, and these are connected in series with a cell having EMF E and internal resistance is also R. Okay? This is what it is given to us. It says the current drawn is I. In this case, current is I. Fine. Now the n resistors are connected in parallel to the same battery, then the current drawn from the battery becomes 10I. Fine. All these n resistors are connected in parallel. Let's see, n resistors, they are connected in parallel. So if we draw it R, this will go n times and connected to the same battery. E will be EMF, R will be internal resistance. So the current becomes 10I. So the current becomes 10I over here. The value of n is, fine, let us see. So first of all, let us see in this case how much will be the current. So beta, current in this case will be E equivalent by R equivalent, right? E equivalent. E equivalent is single cell is there, so it will be E. E by R equivalent will be how much? N resistors are there in series, so it will be how much? NR. The equivalent for this will be NR, and one internal resistance is there, so R equivalent will be NR plus R. Okay? NR plus R. Fine. First we got this I value. Over here, when they are connected in parallel, current is 10I, and 10I will be E equivalent, which is E by R equivalent in this parallel case. How much will be R equivalent in parallel case? R equivalent will be R n times. So what will be R equivalent for all of these? It will come out to be basically like this, R by N. I hope everyone's okay with this. 1 by R equivalent is equals to 1 by R plus 1 by R n times. So it becomes your N by R. R equivalent is R by N. And then you have internal resistance also R. So over here R equivalent comes out how much? R by N plus R. Okay, what can we write it? R plus NR by N. Now if I put it over here, okay, we got it, this R equivalent. If I substitute over here, 10I is equals to E by R equivalent, which is R plus NR by N, or we can write it NR plus R by N. N goes into numerator. This is what we got it. 10I is equals to NE by NR plus R. This is from our second situation we got it. I value is given to you how much? E by NR plus R. That means we calculated it. So let us use first and second equation, and we can write visible here. So 10 into I value is E by NR plus R is equals to NE by NR plus R. Okay, E cancel, NR plus R cancel out. That means N value is 10. N value is 10. I hope all of you understood. Let's look at our next question. Yeah, so the question we have is a filament bulb, the rating for which is given 500 watt, 100 volt. Fine, a filament bulb 500 watt, 100 volt is used in a 230 volt main supply when a resistance R is connected in series. R is connected in series and it is used with the supply of 230 volt. It may be it may be AC or it may be DC, but we have to consider it as your 230 volt is the value of the potential difference. Fine. And the bulb consumes 500 watt. Bulb is consuming how much? 500 watt. The value of R is. Now, interesting question. See carefully over here. Over here, what will happen? Because the rating of the bulb is 500 watt, 100 volt, but it is connected in series with a resistance, the potential difference, this 230 volt, will get divided over here, V1 and V2. V1 plus V2 will be equals to V, which is 230 volt. And it says that bulb is giving it is giving 500 watt, right? That implies the bulb is getting the potential difference, which is its rating. That means for its rating, it has 100 volt, right? So it is getting 100 volt over here, then only it can give power of 500 watt. If it does not get 100 volt potential difference, then it can't give 500 watt. This was the point we need to understand. So V1 value over here, they have given us indirectly as what? V1 value is 100 volt. So V1 is 100 volt plus V2 is equals to 230. That implies V2 value is 230 minus 100, 130 volt. That implies potential difference across resistance is how much? 130 volt. Fine. They are asking us R. How do we calculate? If somehow we get our current passing through this, the current flowing through the circuit, we will get our resistance also, right? How do we find out? We know that over here, this bulb is working at its, according to its rating only. That means it is getting potential difference 100 volt and the power is 500 watt. We know power is equals to what? V into I. So we can write down 500 is equals to 100 into I. That implies current will be your 5 ampere. I hope this point is okay. So that means how much current is flowing in this? 5 ampere current is flowing. If 5 ampere current is flowing through the resistance, 5 ampere current goes. So we can write V is equals to I into R. So V is 130 is equals to current. Just now we calculated 5 into resistance R. So we get over here 5, 2 times 3, so 6. Resistance is 26 ohm. R value comes out to be 26 ohm, right? So this is it. With this, we have completed our discussion. I hope all of you gained some knowledge from it. You learned some. You found your doubt got cleared from this video. And also the thing is, one thing is, in this questions, I have not included the potentiometer question. Reason being that from 2024 syllabus, they have removed potentiometer. That's why you will not find potentiometer question in this video, right? Remaining, I hope you learned something from the video. You found it helpful. If you liked it, just consider to press the like button. Thank you very much. Bye bye.